Today's lesson is on the anthropogenic greenhouse effect. Before we can understand anthropogenic effects, we have to talk about what anthropology is, which is the study of humans both from a historical perspective all the way to the present. So anthropogenic comes from the word anthropology. So this is the greenhouse effect caused by human activity. Anthropogenic means human caused. When we look at all the different kinds of greenhouse gases, if we start off with the principal greenhouse gas that traps and has the greatest impact on trapping infrared radiation in the atmosphere, we have to start with water vapor. So if you look at the diagram on your screen, you'll notice that water vapor isn't even on there because water vapor is a natural greenhouse gas. The majority of the Earth is made up of water vapor, and there isn't any way that we can actually remove the water vapor from the Earth in order to try and get rid of this as a greenhouse gas. And it's also not a greenhouse gas that we have specifically brought and put extra amounts into the atmosphere because of human activity and anthropogenic effects. Water vapor, in fact, is unique because it is a greenhouse gas that exists both in its solid, liquid, and gas form when you consider the average temperature ranges throughout the Earth. Whereas something like carbon dioxide, the Earth naturally will never get to a cold enough temperature where carbon dioxide could potentially become a solid. So this is unique and unusual about water vapor. It's something that allows us to survive because water vapor allows the temperature of the Earth to stay within a range that allows for human survival and the survival of organic life. So therefore, water vapor is the number one greenhouse gas in terms of its effect and its ability to raise the temperature of the Earth. However, water vapor is also a natural greenhouse gas, and it's not one that we produce as a result of burning fossil fuels. The second would be carbon dioxide, followed by methane, then chlorofluorocarbons, which makes up a large group of different kinds of chemical compounds, followed by ozone, and then nitrous oxide. Now, there are some other greenhouse gases like sulfur hexafluoride, which are very powerful gases. They're not on this list because they are produced and they're very strong greenhouse gases, but they're not produced to the same degree as the ones in this list. It's important to understand that there are some natural processes that produce greenhouse gases. So just natural cellular respiration produces carbon dioxide. It is considered a human activity, but it's a human activity that if we don't do, we die. The issues are the effects that are anthropogenic that are caused by excessive human activities. And that's what we're going to get into in the next slide. So if you take a look at the diagram on the page, it shows you the annual greenhouse gas emissions by the different sectors in our environment. In addition to that, it has a breakdown of carbon dioxide, methane, and nitrous oxide and where those all come from. So take a few moments to actually look at that graph, and you'll notice that, for example, there are some interesting things. Methane and nitrous oxide, it is through agricultural byproducts that the majority of those gases are put into the environment. If you look at the larger pie chart at the top of the page there, you will notice that there might be some things that surprise you. Most people, when they talk about greenhouse gas emissions, are primarily thinking of transportation fuels as the main way that we burn fossil fuels. But you'll notice agricultural byproducts is quite high. Power stations is actually even higher than that. And the other one that is really interesting is the fact that fossil fuel extraction, here it's titled Fossil Fuel Retrieval, Processing, and Distribution, actually produces 11% of the greenhouse gas emissions compared to the fuel that then is used by cars and airplanes and so on, which amounts to 14%. So as we just stated, the human activities that produce greenhouse gases are through the burning of fossil fuels, but fossil fuel extraction has a great impact on the amount of carbon dioxide that is released into the atmosphere. Now, these fossil fuels are produced from millions of years of decay from organisms that have then become oil, coal, and natural gas. It's important to also understand that the extraction of fossil fuels releases methane and carbon dioxide. Now, we already know that the burning of fossil fuels produces carbon dioxide. In addition to that, some nitrous oxide is produced as well. But most people don't talk about the fact that the extraction process puts a massive amount of carbon dioxide and methane into our atmosphere and contribute to the greenhouse gas effect. Now, many consider the greenhouse gas effect and climate change as well as global warming as being relatively new ideas, but it was way back in 1896 that Svante Arrhenius calculated that if the carbon dioxide levels were to double on average on the Earth's temperature would increase about 5 to 6 degrees. Now, while his actual predictions and calculations may not have been as exact as what we can do now, he did know way back in 1896 that adding carbon dioxide to the environment was going to have the impact of increasing the temperatures on the Earth. And the effect of increasing the temperatures, while they might not have been known to the extent that we know now, was understood to be detrimental to not only human survival, but survival of a multiple number of species. So where's the evidence for these rising levels? Well, we've already talked in an earlier lesson about the Mauna Loa carbon dioxide levels over the last 50 years, and has been shown to be increasing. Now, again, I just want to reiterate that it's not just the fact that we're adding carbon dioxide to the environment and this is causing temperature increases on the Earth and in a global scale, it's also how fast these increases are occurring as well, which is often a point that gets overlooked when discussions are taking place about climate change, because a lot of times scientists want to focus on the end result, but the end result is quite dramatic when you consider the fact that this is happening very quickly. Often you'll find that climate change deniers will bring up arguments saying that the Earth is massive and it has the ability to go through cycles. It has the ability to take the carbon dioxide and other greenhouse gases out of the environment. It's just a cyclical thing that's going to just solve itself. And one of the examples that's often given is the annual cycle. And it's known that carbon dioxide levels will decrease during the spring and summer months in the seasons in the northern hemisphere. And because the northern hemisphere has the majority of the Earth's land mass, it makes sense that when the northern hemisphere is in its growing season, you have more vegetation. That vegetation acts as a carbon sink. It takes the carbon and it absorbs it into the vegetation, and the global carbon dioxide levels decreases, therefore greenhouse gases decrease as well. And this is just a natural cycle. And often these are arguments that are given by climate change deniers because they say that these are natural cycles that are occurring on the Earth and they're going to continue to occur and everything will turn out fine in the end. However, it's important to also understand that humans get rid of these carbon sinks. So by deforestation as a result of needing lumber, or deforestation as a result of building cities and roads and so on, we are getting rid of our forests and we're getting rid of those carbon sinks, which means that those natural cycles are also being affected. So it's not just the case of humans are, through anthropogenic effects, adding more greenhouse gases. We're also taking away the Earth's ability to naturally go through these kinds of cycles. The best evidence to bring up to climate change deniers is the fact that we can actually look back into the past. So greenhouse gases are able to dissolve in liquids, and liquids, when they freeze, take a snapshot in time of what the environment was like many years ago. And so through looking at the Antarctic ice cores, we're able to find what life was like on Earth before humans were even on the Earth. So there are two videos that I'd like you to watch. Both of them are TED Talks. The first one talks a little bit about how that information from the ice cores in Antarctica are taken and how they give us a picture of what life was like, and specifically what carbon dioxide levels were like and how extrapolations were made to determine what the temperature on the Earth is, so that we can get a glimpse of a couple of things. One is how much carbon dioxide was in the environment and how that has changed, and also how the temperatures on the Earth have changed. So that's the first TED Talk. The second TED Talk has to do with other factors. So Brian Scarry is a photographer who has looked at a variety of different organisms. And through that process, he has actually documented how humans are having anthropogenic effects, not just on greenhouse gases, but on so many other different parts of the environment, which we really need to get an appreciation for, because you may not have realized exactly what a meal that you might have of shrimp actually costs to the environment. So watch those two videos to get a better insight on what we've been talking about in this PowerPoint.